So really quickly, I just want to look at an example of a quadratic that's been graphed and then looking at figuring out basically how to write its equation. It's a little bit hard when the graph is sketched by hand like I did, but I think we can still figure it out. So the first thing we want to look for is just the characteristics that, that we can see right off the bat. So one thing we can see is that the axis of symmetry is x equals 1. We can also see that the vertex right here is at 132. We can see, I counted these by 4s, so 24, 28, 29, 30. We can see the y-intercept is 0, 30. We can see an x-intercept here at 5, 0, and an x-intercept here at negative 3, 0. So those are some of the easiest things to see. And so that's going to give us a lot of information. So if we want to write this in vertex form, standard form, factored form, we can remember, first of all, that vertex form is equal to a times x minus h squared plus k, where hk is our vertex. Factored form we know is y equals a, same a value, times x minus m, x minus n, where m and n are our x-intercepts. And standard form, y equals a, same a, x squared plus bx plus c. So looking at the graph, it should be easier to find vertex and intercept form, and then we can distribute either one to get standard form. So we already know our vertex, we already know our x-intercept, so really a is going to be the only thing that we're going to have any challenge finding. We know for sure that a is negative, and then our question really needs to be, has this been scaled? And has this been scaled? Remember, we are comparing to the parent function x squared, where that looks like this. 234. Right, that looks like this. So we really want to compare it to y equals x squared. And so we need to know some things about y equals x squared to determine whether this thing has been scaled or not. So one thing we notice about x squared is when we move over 1 from the vertex, 1 squared is 1, so we move up 1. So over 1, up 1 from the vertex. Same thing in the negative direction, over 1, up 1. Now if we move over 2, 2 squared is 4. So that means over 2, up 4, right? Of course, this is not a linear function, so our rates of change are going to be changing constantly. So when we go over 1, up 1, but then it gets steeper, so moving over 2, we've gone up 4. So we have different average rates of change here. Same thing in the negative direction, over 2, up 4. So we really want to compare here and say, well, are we moving in the same way or not? So find your vertex. Even though your scale is a little bit weird here, what we can see is if I move over 1, I'm actually going down 2, right? Because I was at 32. I moved over 1 because this is just 1, even though my scale is strange. And I moved down 2. If I move over 2 to here, it looks like I've gone down 8, right? This point right here looks like it's at negative 124. So instead of going over 1, up 1, I went over 1, down 2, and I went over 2, down 8. So compare those. Over 1, up 1, over 1, down 2, over 2, up 4, over 2, down 8. So you can see that really I'm multiplying this by negative 2. I'm multiplying this by negative 2. So that's how you find your a value. A equals negative 2. I've stretched this thing by a factor of 2, even though it's hard to see on the graph. So now that I have a, I can basically just fill in this information here. So I know that for vertex form, y equals negative 2 times x minus 1 squared plus 32. Again, that came from my vertex. I know that for intercept or factored form, y equals negative 2 times x minus 5 and x plus 3, right? Because they should be the opposites of my x-intercepts. And for standard form, I know c has to be 30. And I know a has to be negative 2, but to find b, it's probably easiest just to multiply this out. So I'll get y equals negative 2 times x squared plus 3x minus 5x minus 15. And distributing, I should get y equals negative 2 times x squared minus 2x minus 15. Actually, I combined, and now distributing, I get y equals negative 2x squared plus 4x plus 30. So there I've got my factored form, my intercept form, and my standard form.